Hi and welcome back. So over the past few videos we've been talking about significant figures, and in the last video I gave you the rules for multiplication and division. For multiplication and division we carry the least number of sig figs. So if we have a number with, I think our example was we had one number with two significant figures multiplied with a number that had seven significant figures, our answer was going to have 2, because 2 was the least amount of significant figures that we had in our expression. And then we talked about the rule for addition and subtraction, and then in that rule we carried the least decimal places. And what I'm going to talk about in this video is all about rounding. So the rounding, and this is I guess it's one part where I know I definitely had a question, and I think I definitely had questions about this at the beginning of the semester. Where what is the limit? Do we start rounding up if our one digit past the least significant figure is a 6, or do we start rounding up when it's a 5, or where's the limit? And the limit is always if this least significant figure is a 5. So therefore, like we had in this video where we had 0.705, so we had 3 figures here, but we could only represent 2 of them because we were limited by how many decimal places we were. Our one place past the least significant figure was a 5, so we rounded up. We rounded up to 0.71. So that's the rule. We always round up if we have a 5. So let me just do a couple of quick examples. Let's say we had 1.728, and we had to, so this was the number that our calculator spit out, and say we had to represent this with 3 sig figs. So we have to represent this number with 3 significant figures. What's it going to be? Well, we're going to have 1, 2, 3 significant figures, and then we're going to round up because our significant figure past the least significant figure is higher than 5. So what this is going to be is 1.73 with 3 significant figures, and we round it up. How about, what would this same number be? What would this be with 2 sig figs? Say our calculator spit out 1.728, and we had to write it down as 2 significant figures. Well, then we would just say there are 2 significant figures, and now our new figure past our least significant figure is less than 5. So we don't do anything. We don't round up. So we're just going to say that with 2 significant figures, we would represent that as 1.7. So hopefully that clears up a little bit on rounding. With the one other thing, and it's a very important thing that I do want to say, and I'm going to write it in a very, very bold color. I guess I don't have to number it, but only round. Don't round until you get to the end of all your calculations. So I'll just write down, don't round until the end of the calculations. And this is important. So this is really, I definitely made probably the majority of the mistakes I think I made in the first couple of weeks of chemistry were because I was rounding my answers before I had reached the end of a calculation. So pretty much, if you have a whole bunch of expressions, and I've got an example here. Let's say I had some, and we'll definitely see examples where we will have numbers like this. But let's say I was multiplying out, or I had to do this operation where I had 3.56 times 1.78, and then I was dividing, I'll just write the division as a fraction, I was dividing by 2.69, and then multiplying by 1.005. 2.47, and then dividing by 2.5. That's 2.5. And then finally, I was multiplying by 18.97. So we can see, and based on this information, how many significant figures is my final answer going to have? Because we're just multiplying and dividing here. We're not adding and subtracting, so we don't really have to worry about where our decimal point is. All we have to do is count the significant figures. And we know that we're going to take the least amount of significant figures. So we've got 3 here, 3 here, 3 sig figs here. We've got 1, 2, 3, 4, 5 significant figures here. We've got 4 significant figures here. And then right here is our least our figure with the least significant figures, where we have 2. So our answer here, our answer is going to have 2 sig figs. So let's think about this. If I was going to, let's say I, and you know, I'm making this video as to say that we don't want to round until the end of the calculations. Let's say I started working through this example, and I'll just there so you can just see the numbers, and actually I'll put a little bit of the number pad in there too. So let's say I started working through this example, and let's say I actually started rounding somewhere in the middle. So let's say, or else actually, you know what? Here, to start, sorry, I'm trying not to confuse you. I'm changing my mind at the last minute. Let's go through, I'm going to do this the right way first. I'm just going to multiply all of these and divide by all of these first. I'm going to do all of this calculation and then do my rounding. And that's going to give me the right answer, because that's the right way to do it. I'm not rounding until the end of the calculation. So let's say we have 3.56 times 1.78 divide by 2.69 multiply by 1.0047 divide by 2.5, and then we multiply by 18.97. And we get 17.95. And remember, we can only represent 2 significant figures. And our one figure past our least significant figure is a 9. So we're going to round up. So really what this should give us, what this calculation should give us, the correct answer for this operation is 18. Because we have 2 significant figures, our correct answer is going to be 18. 18 point nothing. Exactly, that's what the correct answer is. This has 2 significant figures. Let's say, though, I started rounding. Let's say I did this much of the calculation, and then I rounded there. And then, let's say after I rounded, let's say I did this much of the calculation, and I rounded again, and then I did the final part of the calculation, and then I rounded another time. Let's see what that would look like. So we've got, okay, so I've got the calculator. So the first thing I'm going to do is multiply and divide these 3 expressions. So I've got 3.56 times 1.78 divided by 2.69. And I get this. I get a whole lot of digits out of this. But let's say, because I just multiplied and divided 3 different numbers that all had 3 significant figures, let's say I stopped here and I rounded. So what am I going to round to? I've got 3 significant figures. So my one figure past my least significant figure is a 5. So I round up. So this is going to be 2.36. And let's just write that in. Let's say all of that, I stopped here and I got 2.36. And then I plugged that. I multiplied 2.36 times this next expression. So I'm going to clear this out, 2.36 times 1.0047 divided by 2.5. And then I got 0.948. So I got 0.948. And remember, I'm only carrying, now I've multiplied a figure with 3 significant figures, multiplied it one with 5 significant figures, and then divided by one with 2. So let's say I rounded here again, and I'm going to carry only 2 significant figures. So this is going to be 0.95. So at this point, I have 0.95. And then let's say I multiplied, finally, I did my last operation where I multiplied by 18.97. So let's clear this out, and I have 0.95, and I multiply that by 18.97. And I get, oh, well, I guess this wasn't the best example. I thought I had worked this out previously. Actually, you know what? Let me see if let me try this again, because I know I got this to spit out, I guess, the wrong answer. So if I took 2.36 times 1.0047, divide by 2.5, and then multiplied by 18.97, it still is giving me 2 right of an answer. I guess I must have done something. I guess I did something different to get this to give me a different answer. Sorry, I guess I'm still getting out an answer that when I rounded I would get 18, and I'm trying to give you an example right now of where if I rounded in the middle I'd actually get the wrong answer. So hopefully you can see that that's what I'm doing, and you'll forgive a little bit of a mistake in terms of the example. But anyway, I'll you know what? I'm going to take a second and try to figure out a better example, and I'll make another video that perhaps if we rounded somewhere in the middle of multiplying and dividing all of these numbers, that we would actually get the wrong answer. So anyway, I'll actually leave you there. In the next video, I'll hopefully have a better example that'll actually demonstrate this concept where I'm telling you, and this is, if you remember anything from this video, it's this: don't round until the end of all of your calculations. And because of this, you can probably imagine, and we'll definitely get into this more further on in the playlist, but you'll see further on that you're going to want to try as hard as possible to put all of your calculations into one expression. And I'll definitely do more on that in the future. But that's, if you take anything away from this video, I hope it's this: it's don't round until the end of all of your calculations, and also try to get a whole big mathematical statement, a whole big operation that's pretty much in one line of calculation. So you can just take a whole bunch of numbers and throw them into the calculator and not have to worry about writing down different figures at intermediate steps. So anyway, I'll actually stop there. So in the next video, I'll hopefully have a better example that actually, I guess, demonstrates this concept where if I did round somewhere in the middle, I'd actually get the wrong answer. So anyway, thanks so much for watching, and in the next video, I'll hopefully have a better example. Thanks for watching.